When analyzing data, you may find two options: direct or inverse trend. But how do you know whether your inverse trend is inversely proportional? Hi, I'm Agufim and I'm going to help you how to interpret inversely proportional trends. Let's go. Okay, so to start, we need to know what is an inversely proportional trend, because obviously if you don't know what is an inversely proportional trend, how you're going to test whether a trend is inversely proportional. So first we're going to see the difference between directly proportional and inversely proportional. If you graph the directly proportional trend, you're going to have a linear function whose intercept is in the origin. If you graph an inversely proportional trend, you're going to have a reciprocal form, okay, that is not going to have any intercept. So this is the difference in the graph. If you want to have a relation, a function rule, so the directly proportional trend will be a constant times x, and the inversely proportional trend will be the constant divided x. So this is the difference between directly proportional and inversely proportional. Other way to show the inversely proportional trend is by writing the multiplication of y and x. It should always gives you a constant. So this is the other option to test when a trend is inversely proportional. Not all the inverse trends are inversely proportional. However, all the inversely proportional trends are inverse. So now we're going to see this in an example, because maybe you can ask, okay, how could you use it in an experiment? How could I use it for an experiment? Here you can see an experiment that I perform in which I measure frequency and wavelength for a string. So you can imagine the experiment in this way. Let me see if I can do the graph. So I'm going to move it here. Okay, so imagine a string, and I took the string and measure frequency, start moving the object up and down with a frequency, and I wanted to know the wavelength of the wave made by the string. And we have these values, okay, so the frequency and the wavelength. You know, it's not so important to understand what is frequency or wavelength here, because we're doing representing inversely proportional trend. If you don't understand, you can tell me and I can do a video that explains what is wavelength and what is frequency. Okay? So when you perform the graph, you can see that this is the form of the graph. So it's probable that our graph is inversely proportional. You can see that the form could be inversely proportional. So far we can conclude or interpret that the relation is inverse. Okay? But we're not sure if it's inversely proportional. You may ask why? Why we're not sure? Because to be sure that it's inversely proportional, it should be this form. Okay, so if we don't have this form or this form, we cannot tell whether the trend is inversely proportional. And this is where you have to be careful, because this difference leads you to make a wrong interpretation of the trend. So now we're going to check how the trend is inversely proportional. Because so far, what we have seen is how an inversely proportional trend is not an inverse trend. And now you know the difference between directly and inversely proportional. So now we're going to test if our inverse trend is inversely proportional. So let's go to see how to do it. So how do you know whether it is inversely proportional? you need to graph the inverse of frequency, okay, or the inverse of our independent variable. And maybe you don't have idea of what is the inverse of our independent variable. So the inverse is just taking 1 over the variable. This is the way we can calculate the inverse of a variable. So for example, in the first case, the frequency was 50, so now we're going to take 1 over 50, and we're going to get 0.020. So that will be the inverse. I use these seconds as units because the units of frequency is hertz, but the inverse of frequency are the units of period that are seconds. So the inverse of hertz will be seconds. Okay, but again, you don't need to understand this thing of units so far. Just bear in mind the idea of inversely proportional trend and you will be fine. So I'm going to graph inverse of frequency and wavelength, and you can see here in the graph the inverse of frequency and wavelength, okay? And what I did was a trend line, so I got a linear trend that relates wavelength and inverse of frequency. And this is the time in which you can tell whether your trend is inversely proportional or not. If the solution is a linear function, if the graph of wavelength and inverse frequency, or the graph of dependent variable and inverse of dependent variable and inverse of independent variable is a linear function, we can say that the trend is inversely proportional. Now I'm going to help you how to interpret these results properly. We have two options. First option, you can see that in my case, I found the slope of the line and the intercept of the line. Okay, you can do it by hand. I did it using a spreadsheet, but you can do it by hand, no problem. So what I got is that the wavelength is equal to 3.36 inverse of frequency plus, okay, actually it's minus 0.00233. Okay, this is what I got from my graph. This is the equation of the line. But we can here take into account many options. For example, the number of significant figures. Look at that here, our wavelength just have two significant figures, okay? And the two significant figures covers until the third decimal place. So it means that this number shouldn't take into account these two decimal places because they're not significant for our work. Maybe you haven't talked about uncertainty, so we're going to leave it this way. And this will be our constant of proportionality. And our constant is going to depend on the number of significant figures. Frequency is going to have two significant figures, and our wavelength, it also has two significant figures, so I'm going to keep two significant figures. So actually our rounded expression should be 3.4 times 1 over f minus 0.002. Okay? And this is our inversely proportional trend. Okay? And we show that it's inversely proportional because it's linear with 1 over f. Okay? It will be an excellent relation if we can discard this factor. If we can discard the y-intercept by saying that it's not significant, it will be completely correlated to inversely proportional trend. But in this case, we don't have this, so it's inversely proportional, but it's not strongly correlated because of this term. So we have to do a change of a scale. That this is what we do when we have directly proportional trends that are linear. So we need to change the scale to fit on a directly proportional trend. So we got to do kind of the same thing. Okay? And this is how you test whether our trends are inversely proportional or not. In this situation, just in this situation, this constant of proportionality, it's due to the velocity of the wave. So, for example, one conclusion should be that the velocity of our wave is 3.4 meters per second. But that will be in this case. Okay? So that's it. That's it. What we learn in this video? What we learn? I'll show you in this video 3 things. First, you learn what is an inversely proportional trend, how to represent it in a function rule and in a graph. Second, how to process data to test an inversely proportional trend. And third, we check the difference between inverse relation and inversely proportional trend. So I hope that you learned these 3 objectives. Tell me if you learned about it. If you have questions, just let me know. Write in the comments. Subscribe to my tube. You know that I'm always open to listen your suggestions and to help you in anything you need. So I hope you have an excellent day and see you in the next video. Bye bye.